In this video, we're going to take a look at inscribed angles. Inscribed angles are formed by 3 points on the edge of the circle. Notice that these are different than central angles that we've previously talked about. Central angles have their vertex located at the center of the circle. To find the measure of an inscribed angle, we need to look at the measure of the intercepted arc. So for example, this piece AC, which is being hugged by angle ABC. We're going to look at the measure of arc AC and divide by 2 to get the measure of the angle. An inscribed angle is half the measure of its intercepted arc. Our next property says that an angle inscribed in a semicircle is a right angle. So in this instance, angle C is a right angle. We can still base this on our property of an intercepted arc is an inscribed angle is half of its intercepted arc. So we can take a look at angle BCD, which opens up to this arc. Well, that arc I know is half of a circle, so 180 degrees. So if I cut that in half, that gets me to 90 degrees for my angle inscribed in a semicircle. Our next property takes a look at quadrilaterals inscribed in a circle, also known as cyclic quadrilaterals. The opposite angles in a cyclic quadrilateral are supplementary. So that means that angle A plus the measure of angle C is equal to 180 degrees. Likewise with the other pair, the measure of angle B plus the measure of angle D is equal to 180 degrees. Our last property for this section takes a look at the relationship between a chord and a tangent and their angle formed. This property says if we take a look at the chord and the intercepted arc, again we're going to take the measure of the intercepted arc and divide by 2 to find the measure of our angle. Same thing holds true in the second diagram, but we're dealing with a major arc, more than half the circle, and we're going to divide by 2 to get the measure of our angle.